you. All right, guys. I only have 15 minutes, and this is quite a big presentation, so let's go through this like really quick. But basically, this is going to be a crash course on wallets, and I think everyone here knows what wallets are. But we're going to be able to actually go through in detail why we want smart accounts and how we're actually going to fix the session authentication for them. So let's start by breaking down the lingo. When we actually talk about like Web3, we're basically thinking about connecting the wallets. And this is just like a shift from like logging in. But it's not that different, because at the end of the day, we end up like having all of these words with like connecting, authorization, and capabilities, and smart accounts. But like we're just reinventing the wheel here under a brand new platform, because no longer we're talking about logging into Facebook or Google. We're actually logging into Ethereum. So that's like a big change here, where we actually have to think about the differences of how this platform is built. And to start off, I want to actually kind of just break down what authentication is as a definition, because it's in a sense a way of verifying that you are who you are. And when you talk to a user, they don't want to like be proving who they are. They just want to like let me in. Like I just want to get in, and you're kind of like blocking my way because I just want to access your application. So the important thing here that we need to maintain for this whole conversation is that less clicks is more. Like as many clicks you have, like the more annoyed your user is going to be. So you want to have as less clicks. And this is like not very true in Web3. And I'm going to explain why is it different. Like I really always like to explain this triangle here, because this is quite a big distinction from what we have in a Web2 world, where we have an app and a server, and then we have this little component here. We have a lot of components. Like inside of the server, it's like a big machine, like full of services. But the authentication part is quite important here, because in blockchain, we ended up moving this into the user's device. So now the user now has an app, and it has a wallet, and essentially we're moving away the authentication from the server into the user's hand, and this kind of complicates things because we kind of break the rule that we created up front, which was less clicks is more. So what is a wallet and what is composed? We have a lot of wallets today. Most people might be using mobile and browser wallets, and some people might be using even hardware devices, but they all break down into this concept of credentials, signing, and an account. And you can see that like it's just several differentiations about like how they actually architect, but they all still kind of have this idea of an external account. So how do you actually have this external account logging in? You use this standard called Sign in with Ethereum, and it looks kind of like gibberish. It doesn't look great, but it's progress, because back in the day, people were like signing a message that was just a hash or just something completely not really great. So when we actually introduced Sign with Ethereum, we actually had a little bit more context about what you're actually signing. And if you start looking in more detail, this actually looks very similar to some of the things that we have. We just haven't built the actual user interfaces that actually create the same experience. But under the hood, it actually works the same. You have the idea of a website, an account, and you wanted to get access, and you have some permissions around the expiration. And then we might even have some resources that we're going to talk about in the future that we can utilize to make these login experience even more powerful. And at WalletConnect, we created this standard called the CAIP 222, which is a chain-agnostic standard. That's why it's not an EIP, which we call Wallet Authenticate. And the reason we created this is because we realized that every time you connect your wallet, you're always asked to sign a message. And this is quite an annoying experience because we want less clicks, and we just decided to like cut off the connect thing, which is kind of funny because maybe we should just change the name of the company to Wallet Sign. And the cool thing about here is that we actually just skip the whole step of connecting and we go straight to the signing, but that actually creates the ability for you to actually just get access into the application faster, and it reduces 2 steps into 1. But is this enough? Like, not really, because we really, at the end of the day, we're here to sign transactions and actually interact with the blockchain. And when it comes to like signing transactions, a lot of people just like close your eyes and approve, but that's also not what we want. We want people to click less, but we also want people to be accountable and informed and make rational decisions. So we need to balance convenience and security. And that's quite an art, because balancing convenience and security is quite contradictory, because usually the more convenient, the less secure it is. So how we're actually going to do this in a way that we achieve the mission of less clicks is more for a better wallet experience. We need to kind of understand how wallets work. Public key cryptography is the core concept that makes wallets possible. And the reason for that is because you have both a public key and a private key. The private key is the one that's secret to you, that only you have possession. And the public key is the one that's actually available for people to actually verify anything that you sign. And the way this works is that you take a message or a transaction, you pass through that private key, and it outputs a signature. And anyone that has that signature can now verify it against your public key. But actually in a blockchain, it's a little bit more convoluted than that, because you actually have like a transaction, which is like a message that you sign with a private key, and that gets you a signature, and then you have a public key, and then that public key is directed to an account. Because most of the time people confuse your public key is your account, but it's actually not true. That's the concept of an external account. And this talk is about smart accounts. So we actually have to kind of move away from this pattern of one public key equals one account. So we have this lingo, which is externally owned accounts, or EOAs, sometimes people call it, and smart contract accounts. And I kind of want to simplify it of, let's just call it external accounts and smart account. We have external accounts today with a private key for a single account, and we want to move to smart accounts. But then again, like, what is an account? Like we have this idea of an account being deployed as a smart contract, which is different from the private key actually owning an account. So if we then had a message to sign a message to verify it, how we're actually going to do this? Because if you have no key, then you have no signature. So how can I actually verify that? So there's another standard called 12721, and this is present in smart accounts today, where it allows you to actually, some code. I don't know why is this useful, but this essentially tells you this is a valid signature. You take some signature for some key, and now you can actually know that this key, or any set of keys, can sign on the behalf of the smart account. So what is an account? If you compare how external accounts and smart accounts work, the big difference is that, as we saw, there's only a single signer or a single key for an external account, and with a smart account, you can actually have multiple signers. But there's even more powerful than that, is that you actually have different payers. In an external account, every transaction that you send has to be paid by the person or the individual that actually signs it, and in a smart account, we can actually delegate this to another party. And a side effect of that delegation is that we can then actually use different curves, because obviously blockchain has a specific curve that you have to use, but there's a lot of devices like iPhones and Androids and tablets that use other cryptography, and it would be more beneficial if we actually extend that functionality. And smart accounts allows us to not only have multiple signers, delegate payments to someone else, and use different curves from the ones. And this kind of creates a big world here where now we have like multiple apps and multiple wallets and one blockchain. And that triangle that we talked before gets a little bit more complicated. But then we actually have like one big smart account everywhere, and it actually makes like managing all of these keys much easier, which is better for the user. But then we actually have to like kind of define, wait, so I no longer have this key, what is actually being connected? So when you actually connect your wallets, you're exposing your account, you read some blockchain data on that address, and you create a session where you say, yes, I am this key, and I sign on this account, and then you request approval from the user, and then from then on you can submit transactions. But this kind of changed with smart accounts, right? So we actually have to rethink about how smart accounts work, and that's where 4337 came, which most people actually know it as the account abstraction standard. But the most important part here is actually the triangle got more complicated now, and now we have an app that wants a wallet to sign something, but now the wallet delegated the payment to the paymaster, and then you have like an external signer that can use for this particular wallet, and then the bundler, what it does is actually takes a lot of transactions and then just bundles them into the blockchain. But actually, we no longer call these transactions, we actually call them user operations, because the actual transaction is what the bundler sends. So all the user operations are signatures from the user saying, I want to do this on the blockchain. And the paymaster, its only responsibility is to pay for the gas. So If we do connect in a wallet, how do we know it supports smart accounts? Currently, it's quite complicated because some people just kind of check if there's code at that particular address, but that's not a written rule. That's kind of just implied. So there's another standard coming up, which is redefining how we actually think about the wallet API. And there's like 4 new methods that is created with this new API, but I think the most important one is this one with the get capabilities, because this one actually tells you if the wallet supports smart accounts and what capability it has. So for example, this is a very illustrative example here where it just says paymaster service supported yes, and maybe it supports like something like session keys. So basically you're getting this exposure to this wallet can do more than your normal wallet because it's not an external account, it's using a smart account. And then if we have this ability to know that the wallet supports paymasters, and maybe we even say which paymaster you'd use, but then every paymaster works a little bit different, then it kind of becomes a little complicated. And ideally, we don't want more fragmentation in this world. We want everyone to work the same way. So we created this standard also called Paymaster Web Service capability, but basically it just says all paymasters work the same way. If all Ethereum nodes work the same way, why should paymasters work any different? So this standard is still not in production, but more and more paymasters are agreeing to reach consensus around the standard, such that every paymaster would work the same way, so it wouldn't be a bigger difference than just using a normal Ethereum node. And if user operations are different from transactions, how do we know every smart account to actually work? Because if every smart account does user operation a little differently, then it becomes a little complicated, just like with the paymasters. So there's another standard for that. There's been so much work going on into smart accounts in the last 6 months. And we have the user operation builder, which basically just has more code, very unuseful for this presentation, but it tells you that there's an interface that every smart account will follow, such that we can construct the user operations for users in a way that it's consistent, no matter if it's a safe or any other 4337 wallet. And if smart contracts also work differently, one thing that Safe has really good is the concept of modules. But not every smart account out there is a safe, and ideally we would like every smart contract out there to follow the same pattern. So there's another standard called 7579, which essentially kind of inspired by safe modules. It takes like a minimal modular smart account interface such that like all accounts would work similarly, and now we can actually have, for example, a module for recovery that is accepted in all smart accounts. So we're actually making a lot of progress because one of the biggest challenges with smart accounts is that they work so differently that if we don't have consistency about all the smart accounts implementations out there, people will not be adopting smart accounts so easily. So if we did all of this work, why don't we just let the dApp sign the transactions or the user operations? Like, isn't it much easier? Why do we still have to connect to the wallet? Like, how about we actually give the power to the dApp to actually just do everything? We have standardized paymasters. We have a standard for signing with the smart account. We have user operation builder. We could add something called session keys. And for me, session keys is pretty much the most revolutionary thing that's going to happen because it's not just the normal embedded wallet experience that people have where you sign in with like your social login and some cloud provider gives you a key that's like secure under their system. This is a key that is controlled by your smart account. A key that can be generated for this dApp and only for this dApp in a way that this dApp can do something in your behalf. And maybe, just maybe, in a couple of years, we might not even need to approve anything and still have control over what the dApp can do. This is possible and will allow us to achieve like the less clicks is more, where we actually have the standard that is pending. I was actually expecting to have the number for the ERC today, but the discussions are still heated, so we need to kind of like reach consensus. And eventually we will have a new standard that actually defines the set of permissions we can actually give for a session, such that the dApp, when it connects to your wallet, you can actually delegate that responsibility for them to have a session key. And with that session key, they will be able to actually sign user operations on your behalf. And this will look something similar to this, where you request the permissions, you approve the permissions, you ask the user if you want to approve the permissions, and this can be done in the resources that we saw. with signing with Ethereum, with that single click, you can actually add to the resources the actual permissions that you're giving to this dApp. And we actually get this little nice experience that we saw with the Google login, where you're giving permissions when you're logging in. And that way, you only click once to log in into your dApp, and you're giving permissions for the dApp to actually sign something. So how can we secure session keys? We just gave session keys to the dApps. We better protect them. We don't want them to get hacked. It would be even better if they don't even have access to the session keys themselves. If only there was such technology available today for us to do that, perhaps we could use passkeys. And in order for us to use passkeys, we need to upgrade the EVM. Like, this is an important step, because if we don't actually upgrade the EVM, like, we're actually building all of this infrastructure on top, and we want to make sure that we actually have this built into the actual Ethereum chain. So there's a standard called 3074 that breaks down the signer and payer. So this would give the keys automatically this capability without actually using the smart accounts. And it's been included in the next hard fork. But we also, what if we wanted to add contract code in more than one transaction? So we want to also persist this code more than one transaction, which 3074 is per transaction. So we could actually use 5003. But then there's also this concept of a 7702, which actually would allow us to have the EUA account code for all transactions, potentially, maybe. Still discussions around that. And we actually would achieve this idea of an external account moving as a smart account. And if we want to prevent session keys from being stolen, we could use passkeys. And if you don't know what passkeys are, you might have seen this in some websites today, where you actually have in your secure enclave in your device a key stored that the website can't access, but it can utilize for some purposes. So this could be essentially your wallet experience. And this would be possible if we upgrade the EVM to 7212, which is currently being considered for inclusion, so they haven't really decided. But this would allow passkeys to be native into the EVM. And this would essentially allow us to be is this the end game for wallets? Have we achieved the fact that before we had authentication in the server, and now we moved it into the app, and we kind of just abstracted the wallet away from actually existing? This would be amazing. And what is actually being connected? WalletConnect started as an intermediary to allow all dApps to connect to all wallets and as this unified protocol. But now the concept of wallet changed, and now we have sessions and paymasters and bundlers and signers. So in a sense, WalletConnect now has to abstract even more components such that you as a user can just go into a dApp and just click. And I think this is what's the true mission for WalletConnect since the beginning, which is to redefine the wallet experience for Web3. And hopefully with this, we actually achieve less clicks is more. And hopefully passkeys become the standard and wallets just evaporate into Ethereum. Thank you.